Hello everyone, welcome back to my channel. My name is Piyush and this is video number 14 in the series TK 2024. In this video, we'll be looking into a very important concept which is taints and tolerations. So this is important yet confusing. Many a times people confuse with it and don't really understand it. So we'll try to understand that from very basic and we'll try to cover the demo as well as some explanation concept over the board. So I hope after this video you will not be facing any issues with taints and toleration and it will be a piece of cake for you. So that's what my plan is, and we'll also be looking into node selectors. So comments and like target of this video is 200 comments and 200 likes in the next 24 hours. I'm sure you will be able to do that. And yeah, let's start with the video. Okay, so let's see how actually it works. So for example, I have three nodes over here, and let's say this one node 1 or node A, whatever it is specialized to run only AI workload because it is running GPUs as well, let's say. So for that, what we'll do is we'll taint this node, okay, with the key value GPU equal to true. Okay, so this is a taint on this node. So now when we have a pod that we are trying to schedule, say this is the pod. Okay, and this pod is something that we are trying to schedule on a particular node. It will first go and check, like the scheduler who's responsible for doing that. It will first go and try to schedule this on this node. But this node has a taint which says only the pods that has GPU equal to true are allowed to be scheduled on this node. So this won't be scheduled over here. Then it will be scheduled on the next available node, let's say node 2. And we have, let's say, one more pod. Again, this pod does not has this matching toleration GPU equal to true. So it will do the same. It will try to schedule the pod on this node, but it will reject. The node will reject the pod and it will go on to the next node or maybe this node. But what we have to do to make sure that the pod that we are scheduling is scheduled successfully on the node 1. So what we'll do, so here is the newer pod that we have. Okay, in this pod, we'll add something called as toleration. So toleration is something that will enable the pod to be scheduled on the node in which there is a taint, right? But this toleration has to be GPU equal to true. I'll tell you how to create that. But for now, let's say we created the toleration with value GPU equal to true, right? Now, when scheduler try to schedule this pod, first it will go to this node and then it will see if it has the matching toleration. Yes, it found it. So it will schedule this pod on this particular node. Now, why did it happen? Because it was able to tolerate the taint, right? So over here, we are not actually scheduling the pod on a particular node, right? We are, I mean, it's the other way around. We are actually instructing the node to accept only certain pods. So this particular node will only accept the pod that has toleration of GPU equal to true. Why we do that? We do that for many purposes. For example, in this case, let's say this node is a bigger node. It has GPUs running, it has extensive memory and other resources. And we only want this node to be specialized for AI workloads, right? So that is why, with the help of toleration, we are telling that this pod is an AI workload, is running the AI workload. That's why it has to be scheduled on this particular node, which is specialized to run AI workload. And any other pods which are running non-AI ML workload can go on either of the other nodes available. So this is what toleration does. Over here, we have seen toleration has a key value pair which suggest what type of toleration or what type of taints to tolerate, right? Taint, we do that on node, and toleration, we do that on pod. So remember this point. So I'll just add it over here. This is a taint, and this is a toleration which was on the pod. Let me add it over here as well. Just to avoid any confusion, I'm going to add it over here. So this is the toleration on the pod. Now it has a few more things. So we have seen the toleration has a key value pair, and it also has something called as effect. Effect is the scheduling type. Like it could be one of threes. So it could be either no schedule, okay, and it could be either let's have a look at the taints and toleration. So there is no schedule, and then we have no execute, and I guess there's one more. Okay, so there is no schedule, then we have prefer no schedule. Let's move it over here. And then we have no execute. I'll tell you the difference between each of those. No execute, and this schedule has to be a upper caps S. And these all are nothing but effects that we have to specify with the toleration, and it'll be in the taint as well. So how does it work? When we specify one of these effects, it works differently in each of the scenarios. For no schedule, it will work for only the newer pods. Okay, just add it over here. It'll work on the newer pods. For no execute, it will work on all the existing and newer pods. So that means if we use this effect on toleration, it will check if there is any existing pod as well running which is not tolerating the taint, and it will evict it. But for no schedule, it will work only on the newer pods. So whenever we are trying to schedule any pods, and it will check the toleration if it is tolerating the taint. And prefer no schedule, it tries to apply that, but it does not guarantee it. No guarantee of the pod's scheduling for that particular taint and toleration. But this is how it works. Now let's have a look at with the help of an example. So we'll go to our Visual Code Editor over here where we have our cluster running. So let's see what we have already running. We have a few pods running. So let me delete those. I'm gonna do some cleanup. Nginx and Redis, and basically that's it. Now let's see what nodes do we have. So we have 3 nodes, 1 control plane nodes, 2 worker nodes. I'm gonna add a taint on both of the nodes, nodes, worker 1 and worker 2, and then I'll try to schedule a pod. So let's try to taint the node first. So command for this is kubectl taint node, and then the node name which is this, and then we have key value pair. So key value, let's say GPU equal to true. So that's the key, that's the value. And this is the taint that we are adding on the node and instructing the node to only accept the pod that has GPU equal to true. Okay, and for the same effect. So effect, let's say no schedule. All right. It says unsupported taint. Maybe there is a spelling mistake, but let's do a quick help on that. -h and no schedule with N capital as well. So yeah, I made the mistake with this. No schedule. Okay, so now it says the worker node has been tainted. Let's apply this taint on the other worker node as well, which is worker 2. Okay, now quickly have a look at that. kubectl describe node. Okay, and the node name is this. You can grab and look for taint, or maybe it is capital T. Let's see. Okay. Yeah, it's taints with the capital T. So now it is showing that GPU equal to true and no schedule, the taint is there on the node. Okay, so now let's try to schedule a pod. Run and nginx hyphen image equal to nginx. Okay, enter. Now do a kget pod, and now it says it is in pending state. Why? Because this pod does not have a toleration to tolerate the node taint. Right? So that is why it is stuck on pending. And now if we do a describe on this, so kubectl describe pod, this pod, and let's see the error message. It says 0 out of 3 nodes are available. One node has untolerated taint, which is kubernetes.io/control plane. So this is the taint that we already have on control plane, and two other nodes had untolerated taint GPU equal to true. So we have 3 nodes, one with the taint for only control plane workloads, and 2 other nodes that we have tainted with GPU equal to true. So this pod is not able to fit in any of the available nodes. And it says preemption 0 of 3 are available. Preemption is not helpful for scheduling. So that means we are not able to schedule any this particular pod on any of the node unless we have the toleration. Okay, so what we'll do, we'll create a toleration on this particular pod. So, or maybe let's create a new pod. kubectl run. Let's use a Redis image, hyphen image equal to Redis, and I'm gonna do a dry client. Dry run equal to client hyphen o YAML, because I have to make the changes in the YAML. We cannot add toleration from the command line. Okay, so there is the YAML. I'm gonna, okay, let me move inside the day 14 folder first. And then I'm gonna redirect this to a new file, redis.yaml. Okay, we have a file over here now. And to add the toleration, we go inside the spec and at the container level, at this level, so after restart policy, we add tolerations. Okay. And if you want to verify the syntax of it, you can go back to the documentation, Taints and Toleration on the same site. So basically just search over here. It will be the first link that I have opened. And this is the format, okay? Toleration, key operator value effect. So I'm just going to copy this. Okay, so let's move it 2 spaces to the right. All right, so we have the toleration over here, key, and it has to be like everything has to be in double quotes. Key is GPU and operator, that means equal, because we can use equal to, not equal to, and in, and like to select from the multiple operators, we can do that. So that's why operator is equal and value is true. So when GPU equal true and effect is no schedule, right? This is the toleration. Now, if we apply this, I-f redis YAML, and let's see what it does. It is in running state. Okay. And if we do kubectl get pods -o wide, and you see this is running on worker node 1 because it was now able to tolerate the taint. Right, so that's why it's been scheduled. But the first pod, nginx pod, it's still in pending because it does not have the toleration. So let's remove the taint from node 3 and let's see if it was able to schedule the nginx pod. So to delete the taint, what we'll do is kubectl taint node name was worker 2, and let's do a help on that. It does not show, or maybe there is a different command for that. Let's go to this and let's search for untaint, or let's go to our cheat sheet. It should have the command. and let's search for taint. Okay, this also does not have it. Delete the taint. Let's this. Oh, okay. It's pretty simple. We just have to add a hyphen at the very end. I forgot that. So let's uh, use the taint command again, and we have to add key value, which is, let's say, what was the taint on kubectl describe node, and this node grep taints. Okay, so I'm gonna copy this a taint node tk cluster 3 worker 2 on the second node, and that key is GPU, value is true, and the effect is no schedule. Okay, and we have to add hyphen at the end. So this will remove the taint. It says it's untainted, and if we do the describe and grab taints again, it does not have any taint. And if we do get pods now this nginx pod is scheduled. And if we do describe, or no, let's do a get pod hyphen o wide, nginx pod is scheduled on worker node 2 because we have removed the taint now. Okay, so I hope this taint and toleration concept is clear now with the help of an example that we have just seen. So you can try it out yourself, add some taints, remove some taints, add toleration, remove it. And basically, this is why we use it. So it has different purposes. Like one we have seen, if we are using a specialized node for running a specific type of workload, or our control plane, for example, has a taint by default to prevent any custom workload to be scheduled on that node. That means only control plane components and the system components should be scheduled on the control plane node. That is why it automatically added a taint on that node, right? So that's what it will do. And then we have a concept of selectors. So the way selectors work is, let's say we go back. Okay, so over here we are telling the node to only accept a particular type of pod, but it is not guarantee, right? So let's say this particular pod that we have, it was scheduled on this particular node because it was able to accept it. But what if the scheduler tried to schedule this particular pod on this node? We did not have any taint on this node, so it would have scheduled it, right? So this does not guarantee, like taints and toleration just prevent or restrict unwanted pods to be scheduled on a particular node, but it does not guarantee that only those particular pods will be scheduled on it. So this pod can go over here or here as well, right? It restricts what pods are scheduled on this node. So to avoid that, or to add some more functionality to it. So yes, this is really important, and we always use taints and toleration in production environment and everywhere else. But we add few more features of scheduling. For example, selectors. Okay, so what selector will do, instead of node make that decision of what type of pods to accept, will give the decision to the pod to which node it has to be deployed on. So we do that with the help of labels. So again, instead of GPU true as the taint, we use GPU equal to false, let's say, as the label. So we add this label on the particular pod, and now we say the pod to match this label with the node label. So the node have this label as well. So we'll add the label on the node as well. Let's say we added this label on both the nodes. Now, what it will do, it will first try to check that if any node is available with this matching label. So it sees that yes, this node, so it will schedule the pod on this node, or if it can be scheduled on this node as well. So in either case, the pod will be scheduled and it will not go to this node because this node does not have the matching label. Even if it would have gone over there without the label, it would not have tolerated the taint on that node. So the pod will be scheduled over here with the matching label. Now let's see how this can be done. So I'm going to go on my Visual Code, and I actually had to record it twice because my mic did not work in between. So I'm recording it again. That's why you already see a few files over there. So let's delete this, or let me pause the video and do some cleanup first. Okay, so I did some cleanup. Now let's create a new pod. Let's use kubectl run nginx new hyphen image equal to nginx, and I'm gonna do a dry run equal to client, and I will also be generating this as a YAML. Let's create a new YAML, new nginx.yaml. We'll be making changes in the YAML. So over here, new nginx, go at the same level, container level, and add a new field which is called node selector. Okay. And inside that, you actually specify the label. So if we do GPU equal to false, right, it will match this label to the node where the label is applied, and it will schedule this pod on that particular node. If it has multiple nodes, then it will select in one of those nodes. If we do a save, and if we do a kubectl, oops, not here, kubectl apply -f new nginx.yaml get pods, says it is running. And where it is running, ctl describe pod, it is running on this worker node because it has the matching label. Let's see if it has the matching label. ctl get nodes -show labels. Okay, so worker node this one, and I already removed the label from it, but somehow it took the label from it. It does not have a label because I removed it. So it should not, maybe the pod was already running. Oh yeah, the pod was already running. So let's delete the pod once. Nginx new. Okay. Let's apply again. Apply -f new nginx. Okay, and now let's do a get pods. Now it is stuck in pending. And if you do a describe on this, you will see it says 0 out of 3 nodes are available. One has untolerated taint, which is your control plane taint, and 2 nodes did not match the pod's node affinity or selector. No, because this selector that we have, no nodes are available that has this matching label. So let's try to label one of those nodes. So get nodes, and then I'll just copy it, and to add the label on the node is adding it's same as adding the label on the pod, basically the same command with a few details. So kubectl label node name, and then label is gpu equal to true. Okay, sorry, gpu equal to false. Okay, so it says it's been labeled, and if we do show labels now, here is our label gpu equal to false. Okay, and now if we do a get pod, the pod is now scheduled, and it should be scheduled on node 1, which we have just labeled. So let's see, nginx new and ck cluster 3 worker, which is our node 1, and it has scheduled on that node. It matched that label and it's scheduled on that node. So it is important to understand the difference between node selector and taints and toleration. So taint and toleration works as a restriction applied on the node. So node makes that decision what type of pods to accept. But with node selector, pods take that decision on which node it wants to go, right? And there are some limitations with node selectors, like we cannot use some expressions, we cannot use logical and, or we cannot add more conditions to it so that it can be scheduled on one or more nodes, right? So for that, we use a concept in Kubernetes called node affinity and anti-affinity. So that will be covering in the next video, but I hope the concepts that we have discussed till now is clear to you and you have done enough practice. As always, there'll be a assignment task in the day 14 folder in our GitHub repository. So try to complete that, and you know where to reach out if you face any issue on Discord and over here in the YouTube comment section, and someone will help you out. So yeah, thank you so much for watching this video. Please try to complete the comments and like targets for this video as always, and I will be publishing the next video in next 24 hours or as soon as the target is completed. And basically that's it, and thank you so much for watching, and I hope you have a good day.